Now, we have moved on to the third lecture of this series, that is basic signal systems. So, today topic is in the unit 1 we are discussing about the classification of signal and their mathematical representation. So, today we will discuss how we can classify signal into various type and how we can represent a signal, given signal, in mathematical forms. Okay, so let us proceed, continue. So, we have already discussed that basically there are two types of signal, one is continuous and other is discrete. So, what do so continuous signal, just we can revise. Continuous signal means a signal which is having a value for all instant of time is basically a continuous signal, or and a signal which is not having a value for all the instant of time, that is called as discrete signal. For example, suppose if I draw a signal which is having a value only at, suppose this is a time which is having value only at particular time, then this signal will be called as discrete and this is basically continuous signal. Okay. So, now let us start with the very basic type of signal is unit step function. What is unit step function? See, a signal which do not have any value till t less than 0, but it has a value only after t greater than or equal to 0, then that is signal is basically a step signal and the value it having is constant. For example, see, unit step function, it is having no value before t less than 0 and it is having a constant value, that is 1 at t greater than 0, and so basically the average of the signal is at t is equal to 0. So, this is the representation of unit step function. See, it is like at t is equal to 0, this is t less than 0 and this is t greater than 0. So, this is having a value 0 for t less than 0 and a value of 1 by 2 at t is equal to 0 and 1 after t is equal to 0. So, these type of signals are called as unit step signal, and basically when we see this signal in the network, then we represent basically a voltage, we can represent a voltage signal by this step unit signal. Suppose for a circuit, if we want to represent this in a form, this is 5, that we can say that we can consider this as a unit step signal. We can also write this like this. Basically, this is unit step. Okay. So, moving on to the next signal. Next signal is signum function. See, what is the graph of signum signal? See, this is the graph. What is it is showing that the value it is having t is equal to minus 1 at t less than 0 and t is and at t greater than 0 it is having a value plus 1, and the transition is taking place at what, t is equal to 0. So, from minus 1 the signal is shifting to plus 1. So, this type of characteristic whichever signal shows, that is called as signum system. Also we can see, suppose if we want to write this signum signal with the help of unit step signal, how can we write? See how this is basically signum and this is basically step. Now, if we want to represent this signum function in terms of unit step, then how can we do? See, just add 1 to the signal. If you add 1 to the signal, then what will happen? See, adding 1, then signal become like this. The signal will shift towards x axis and it will become like this, and earlier which and the value will become 2. Okay. But in order to but the only difference is unit step is also having same characteristic, only the here magnitude is 1. So, here it is 2. So, what we can do? We can divide by 2. So, if we divide by 2, we will come to here. So, that means 1 plus signum by 2 is unit step. Okay. So, if it is asked how we can represent a signal in terms of unit signal, so we can say it is 2 unit step signal minus 1. Okay. So, the next signal is what? Ramp signal. The second is ramp signal. So, basically how we represent a ramp function? How we represent a ramp function? See, a signal which is having some slope and is this signal also exists only for t greater than 0 and for all the values or all the time t less than 0 the signal is having no value. So, how we represent? Suppose here when what is slope of the signal? The slope will be 1. So, basically the way of writing the signal is ramp t is slope into t. In case here the slope was 1, so it was 1 into t. Suppose there is some graph like this and this value is 4, the time is 2. So, for this if you want to write the ramp signal for this, we will write it as what is the slope? 4 by 2. What is the slope? Y by x, it is 2 into t. This is the value of, this is the way how we can represent a ramp signal. So, this is the ramp signal. Okay. And what is unit ramp? When the slope of this ramp is 1, then that is called as unit ramp. Okay. When the slope is 1, that is called unit ramp, and if there is any value of slope which is other than 1, we can say that is simply a ramp function. Okay. Now, moving to the other signals, this is one of the example which is of rectangular pulse signal. So, what is that value? Rectangular pulse signal means a signal which exists. See, till now we have studied 3 signals, that is unit pulse, no, not pulse, basically step, ramp. Both of those signal were having no values for t less than 0, but now rectangular pulse or now whatever function we will be studying, that will be having a value for t less than 0 also. So, see here. So, if what is about this signal? This signal is having magnitude 1 upon a and also exists for minus in minus time duration and also in positive. So, here you can see this is, and also you can see there this signal is also symmetric, you can say symmetric. Now, later we will see what are the different type of symmetries. Basically, we have 2 types of symmetries, odd symmetries and even symmetries. So, basically this is example of even symmetries. See, if we consider this y axis as a mirror, then we can say this image, these both are mirror image of each other. If you consider this as an object, then this is the mirror. If you consider this an object, this is the image. So, this is basically a representation of rectangular pulse. Now, we are coming to next signal or next function, that is unit impulse. So, what is different between the rectangular and unit impulse? See, in the rectangular signal, if we try to squeeze this time duration, to smaller duration, or if we squeeze this to t, then we can say that this signal is, an impulse signal, and here the magnitude is 1 by a, but in impulse function it will go up to infinite. Means if you want to represent a unit impulse function, then it will be like, you can just like it, right. So, the value only exists for t is equal to 0 and for all other value it is 0. So, basically, so whatever were the signals, there was one signal which were having values for only for positive value of time, there was a signal which were having value for negative and positive both. Now, this is a type of signal which is having a value only for t is equal to 0. This is the signal is having value only for t is equal to 0. This is 0 value for t less than 0 and also 0 for t greater than 0. So, this is the third type of signal. So, I have discussed how we will represent. See, this is the representation. You can see the value of signal is only for t is equal to 0, only for t is equal to 0, and this is the area. What I have told, that if we try to squeeze this into a smaller duration, see, do it like this, or further if you squeeze like this, means the area should be 1. This is a rectangle, so rectangle area should be 1, then this makes a unit impulse function. So, it is also area under an impulse is also called as strength or weight. So, this is the basically the signal and this is the value of area. So, if the area is value of area is 1, then we will call this as unit impulse, and if this is here area is 5, here area is 5, and so we will call it is not a unit impulse, but it is a impulse function with weighted value with strength or weighted value of 5. Okay. So, later we will see how we can, if we have shifted the signal to the right, then how we are writing t minus 1. In the operations on signal we will see how we will be able to modify signal, or we will be able to move signal from in time domain. Okay. So, these are the basically impulse, and one more thing here we need to notice, see, in all the system when you will be studying about the properties of systems. So, in properties of system basically LTI system. What is LTI system? LTI system means linear time invariant system. So, we will see this later what is LTI system. What I want to discuss here is, in LTI system, whenever we want to find stability of a system, if we want to find property of a system, what we will have to do? We will have to give one signal. So, for LTI system, what type of signal we give? So, what we have studied? We have studied unit step, we have studied ramp, and we have studied impulse. So, what we do? We give impulse function, we give impulse signal to all the LTI system in order to find out the behavior of the system. What is the advantage of impulse signal? See, basically whenever suppose there is one system, and you are providing one input and here you are getting one output. So, basically the output consists of two parts. One is transient response plus steady state response. Okay. So, when the output is dependent on two values, transient response and steady state response, where transient response is due to the properties of system or due to system properties, where and the steady state response is basically due to the type of signal. Okay. See, so basically if you want to find out the property of the system, so what we do, basically we need those output which is totally dependent on the system properties, but in output we are also getting the output is also consisting of some part which depends on the nature of signal. Okay. So, in that case what we will do? What we will do is, we should choose such type of signal which does not carry any value for long duration of time, because if we are having any signal which is having some value for duration of time, then that will give a steady state value. So, that is why if we choose impulse as a function or impulse as a signal, what it will do? As we know that impulse only have value at t is equal to 0 and it do not have any value for t less than 0, t greater than 0, then that means if we give impulse signal as an input to any system, it will have only transient response, and this transient response what it will do? This transient response will tell us the property of the system. So, we will be exactly knowing what is the behavior of the system. So, this is the advantage of using impulse function as a input to the system, and when you are required to find the properties of the system. Okay. So, basically these are the 2 to 3 properties of impulse function. See, what is the one property? If you integrate the delayed impulse function with respect to some function, then the value of that function at t naught is the final output of this signal. For example, suppose if you take x t and del t minus 2 from minus 5 to plus 5, and if you want to find out the value of this integration, then the value of x t at t is equal to 2 will give that is value x5 will be the total response of this equation. So, this is called sampling properties of impulse. Second thing is scaling property. So, what is scaling property? If you expand the time, or if you expand the time, or if you delay the time, or if you compress the time, that is called as scaling or decaying property. So, suppose here what I have done, we have scaled the time duration. So, what is the change in the response? The response is only, signal is as it is, only the magnitudes has reduced by that value by which there was scaling done in the signal. Again this is convolution, we will later see what is convolution. Okay. So, whatever signal we have studied, that is step, unit impulse and ramp, that was for continuous signal. Similar thing exists for discrete signal. So, what this is basically the unit of discrete signal, then this is for unit triangle for, now this is okay. So, this is was for discrete. So, again, here again there is convolution, we will see later. Now, again another function is sinc function. So, what is sinc function? See, this is the mathematical representation of sinc function, sin pi t upon pi t. So, see what I have signaled this, the signal is having values for both greater than t greater than 0 and t less than 0, and at t is equal to 0, and the value, the magnitude of this signal is decaying with respect to time, and this signal is also symmetric with respect to y axis. So, if we want to write, what we can write, see the signal is symmetric with respect to y axis, that means is example of what? Is example of even signal. Also we have studied that there are basically three type of signals, classification of signal we have studied, that is we have energy signal, power signal, or neither energy nor power signal. So, if you try to classify this signal, what is the classification of the signal, we can say that this signal is of what type? Energy signal. How we can say energy signal? How we were able to find the energy signal? See, any signal which is having decaying magnitude, which is decreasing in with respect to time, that comes under example in the category of energy signal. So, it is very easy to identify energy signal. We have to look for two things. Suppose if any signal is having finite duration, if any signal is having finite duration, or if any signal is having infinite duration, and in that case it should have decreasing magnitude. So, if any signal, for example, suppose this is a signal which is having finite duration, it is existing from t is equal to 0 to t is equal to 2. So, we can easily say the signal is example of energy signal. Again, but if there is, suppose there is sinusoidal signal, sinusoidal signal is existing from t is equal to minus infinity to t is equal to plus infinity, but the magnitude is constant, it is not decaying. So, it will not be the category of, but if we see this signal sinc function, it is having duration is infinite both the side, but it is decaying in both the axes. So, this is example of energy signal. Okay. So, what I have told, this is basically the representation of a continuous signal into a discrete one. Suppose this is the signal, if you want to represent into a discrete signal, what we will do? We will divide the signal into a small duration, then we can easily represent this signal. Like this. Okay, this is the representation of continuous signal into discrete part. This is the representation of discrete unit step function. See, this is similar to the continuous signal, only we have to break the signal into small part. This is for ramp, this was for ramp for in this case of continuous signal, this is for discrete signal. Same was, this was the representation for a continuous signal, this is for discrete. Again, now we have already discussed this classification of signal. Okay. So, now see, this is important to discuss what is periodic and non-periodic signal. See, basically, see any signal which is getting repeated after certain duration of time, that signals come under category of periodic signal. Also, if any signal, suppose if any signal is periodic for suppose t is equal to pi. For example, if you take example of sine or cos, so sine is periodic for what? Time, sine signal or sinusoidal is periodic for what is the period of sine? This is the representation of sinusoidal signal. So, what is the period for sinusoidal signal? It is 2 pi. So, if any signal, if it is periodic for 2 pi, so we can also say it will be also periodic for nt, that is means n into 2 pi. If you keep n is equal to 1, n is equal to 2, it will also be periodic for 2 pi, 4 pi, 6 pi. So, that means if any signal is so what is 2 pi? The time period is basically the fundamental time period, which is the smallest duration. The smallest duration of time for which the signal is periodic, that is will be the fundamental time period. And this is basically the representation of sinusoidal signal. Okay. Now, suppose now if we add two periodic signal, then result can be periodic or can be non-periodic. It depends on some criteria. What is that criteria? See, if both two signals are periodic, if there are two periodic signal, if we add them, if the ratio of their time period is a rational number, then that means the output of the signal will also be a periodic signal. For example, if you check here, there are two signal, one is having time period of 6, another is having time period of 8. So, if you find the ratio of 6 by 8, you will get 3 by 4, which is a rational number. That means the sum of these two periodic signal will also be a periodic. Okay. So, this is basically what we have discussed. Even signal means the signal which is periodic about y axis is even, the signal which is periodic about origin, is odd. So, see this, this is image is origin periodic around, this is image around origin. If you see this signal is what? Periodic around y axis. Again, if you see this image or this signal, this is periodic around origin. Also, see how we represent any signal in a even and odd part of the function. Just gt plus g minus t by 2 will give you even signal, and if you subtract those, you will get odd signal. Any function whose even part is 0 is odd, and any function whose odd part is 0 is even. Suppose if you break a signal, also one thing, any signal can be, suppose from here example, if you add 1 and 2, what you will get? See, if you add 1 and 2, you will get GET plus GOT. Here you will get, if you add both, you will get GT to GT by 2. So, you will get GT. That means, if you add a signal, even and odd part of signal, you will get exactly a signal, or other way you can say any signal can be written down in the part of its odd and even part. Any signal can be written down in a summation of their odd and even part. Okay. So, this is the basically if we are combining two signal, then what will be the result? See, if you suppose there are two signal, both even, both odd, or one is even, one is odd. So, what will happen? If you add both even signal, you will get even signal. If you add both odd signal, you will get odd signal. So, how to remember this table? See, just remember, if you consider even as a positive sign or odd as a negative sign, then you can easily remember this table. For example, see, if you add both even numbers, so means if you add two positive number, you always get a positive number. If you add two negative number, you will always get a negative number. Similarly, see the product, if you add two positive number, you will get positive. If you multiply two negative number, you will get one negative number. Similarly, see, but see that this case is important. If one is positive and one is negative, so you cannot say what is the sign of the sum, because it depends which number is greater. So, when number is even and another is odd, so you cannot get sum, you have to tell the magnitude of the value. You cannot determine sum or difference. Also, although you can define product, how? See, when you multiply a positive number with a negative number, obviously what you will get? You will always get a negative sign. So, product of an even and odd is always odd, and product of division of even and plus and minus will always minus. Suppose plus 5 by minus 2 will always give minus 2.5. So, this is the case. So, remember, even signal is positive and odd signal is negative, you will be easily able to find this table. This is same representation in the form of, see, when you are multiplying two signal, how you multiply two signal. See, this is the product of an even and odd. So, what is we are saying, if we multiply even function with an odd one means positive multiply with negative, will always get what? You will always get a negative sign. Okay. So, negative sign means what? See, basically this is the negative sign. Again this is the representation. See, this is again you are adding two odd numbers. So, two odd number means negative into negative means what? You will get positive. Positive means what? Positive means even. So, even signal is what? Even signal is always symmetric around y axis. So, that means from here also you can confirm, from here also you can confirm that whenever you multiply two signal to odd signal, you always get a even signal. How you can say it is even signal? See, because it is symmetric around y axis. This is the tabular form and this is for the discrete form. Okay. So, let us take few example also. If you want, suppose if you want to write now since you have seen the basic of a signal, suppose if you want to represent any signal like this is form, if you want to write this signal from the summation of what you have unit step only. If someone asks you represent this signal in the unit step form or by using unit step signals make this signal. So, how we will make? So, we will see this in the properties of signal, we will see this in properties of signal. So, what we have studied is where basically there are three basic signals. What signals are those? Those are unit step, second is unit ramp and third is what? Impulse. There can also be different signal like suppose there is parabolic signal. What are parabolic signal? A signal which is of this shape basically is a parabolic signal. Okay. We represent it by t square by 2, x t is equal to t square by 2 is a representation of a parabolic signal. So, this is the, so basically these are the three signal which we continuously use in signal in order to derive suppose using these three signal we can derive any other signal. So, that is why these are called as basic signals. So, in next lecture we will see what are the basic how we can do different operations on signal. Suppose if I am having one signal from t is equal to 0 to t is equal to 2, but I want to expand the signal to t is equal to 0 to t is equal to 4, or if you want to compress this signal from t is equal to 0 to t is equal to 1. So, these will be done using different tools or using the operation that we will call as operation on signals. Okay. Thank you.